Today, I will be discussing a fascinating problem known as the egg drop puzzle and how we can solve it using dynamic programming. This puzzle not only provides a great mental exercise, but also offers practical applications in various fields. Introduction to the egg drop puzzle. Today, I will be discussing a fascinating problem known as the egg drop puzzle and how we can solve it using dynamic programming. This puzzle not only provides a great mental exercise, but also offers practical applications in various fields. Optimal substructure. We can calculate and figure it out using the optimal substructure, but it would be so complicated and not easy to understand. Therefore, let us introduce the egg drop puzzle using dynamic programming.
In the problem of determining the highest floor from which an egg can be dropped without breaking, we face two possible scenarios. Let's explore both. Case 1. The egg breaks when dropped from floor, F. When this happens, our problem is reduced to determining the highest safe floor in a building of height, F1. Additionally, we now have one less egg to work with, meaning we have K1 eggs remaining. Case 2. The egg does not break when dropped from floor, F. In this scenario, we need to check the remaining N, F, floors above floor, F. Importantly, we still have all K eggs available for further tests. So in short, dropping an egg from floor, F, gives us two outcomes. If it breaks, we reduce our problem to the lower floors with fewer eggs. If it doesn't, we continue testing the higher floors with the same number of eggs. Let's see how to calculate. Assume that we have a 9th floor building and 3 eggs. Then consider the first egg and we can't know which floor we should choose to drop this egg from. So, we will simply consider every case. That is, we'll consider dropping the egg from every floor and choose the case which returns the minimum attempts. This is the basic function of egg drop n, k. N is the number of floors, k is the number of eggs. Then we will consider each floor and write the subproblem functions corresponding to it. For the top row, it will be 1 plus maximum of egg drop n minus 1, k minus 1, egg drop 0, k. So here, egg drop n minus 1, k minus 1 represents case 1. That is, when the egg breaks, we look at the bottom floors only. Egg drop 0, k similarly represents case 2. That is, when the egg doesn't break. We look at the top floors, and there are no floors at the top. This will return 0. Similarly, for each floor, we will do the same thing. Here is the formula to solve egg drop puzzle, where I represents the number of eggs and J as number of floors. To calculate the egg drop puzzle, we use this formula and put the result in the table one by one. Let's see how to solve. Look up find maximum. Let's fill the table for the following case. Floors, DARs 4, eggs, Rs 2. For egg 1, each case is the base case, so the number of attempts is equal to floor number. For egg 2, it will take 1 attempt for first floor, which is base case. For floor 2, fast, taking first floor 1 plus max 0, dp. Taking second floor 1 plus max dp 0, dp ta ya min 1 plus max 0, dp 1 plus max dp 0. For floor 3, as, taking first floor 1 plus max 0, dp ta. Taking second floor 1 plus max dp, dp. Taking third floor 1 plus max 0, dp, dp ta min all 3 floors. 2 for floor 4, taking first floor 1 plus max 0, dp. Taking second floor 1 plus max dp, dp. Taking third floor 1 plus max dp, dp. Taking fourth floor 1 plus max 0, dp, dp, min, all 4 floors, number 3.
Let us take a look at dynamic programming function to get minimum number. In worst case, egg floor is our array, res is result variable, and ijx iterations. We need 1 trial for 1 floor and 0 trials for 0 floors. Similarly, this is our second condition that we always need J trials for one egg and J floors. Now we will fill the rest of the entries table using the optimal substructure property. For each states X, we will break into two parts where the egg breaks and the egg doesn't break. This condition is to check the minimum of all the values that we had got. Then the RES value is updated. Egg dropping puzzle using memoization. Follow the below steps to solve the problem. Declare a 2D array memo of size n+1 into k+1 and call the function solve egg drop n k. If memo at Seng k was already computed, then return memo school. If k equals 1 or k equals 0, then return k, base case. If n equals 1, return k, base case. Create an integer min equal to the integer maximum and an integer res. Run a for loop from x equal to 1 till x is less than or equal to k. Set res equal to maximum of solve egg drop n1 x1 or solve egg drop n kx. If res is less than integer min, then set min equal to res set memo. Egg dropping puzzle using space-optimized DP. Create an array DP of size n+1 and an integer m. Run a for loop from m equal to 0 till dp or k. Run a nested for loop from x equal to n till x is greater than 0. Set dp's equal to 1, plug dpx1, return m.
Let's talk about its application in the real world. In building safety testing, earthquake resistance, we determine the highest safe building floor under simulated seismic activity with minimal tests. In product durability testing category, gadget drop tests, we use to find the maximum height from which electronic devices can be dropped without damage, reducing test numbers. In medical dosage trials, we identify the safest and most effective drug dose with the fewest clinical trials. Agricultural testing in crop resistance field, we determine the maximum stress, e.g. drought, crops can endure, minimizing test scenarios. For manufacturing quality control, the method ascertain the highest load materials can bear before breaking, with fewer test iterations. This is the end of our video. Hope you enjoy and understand the concept clearly. Thank you so much for your time, and this is Pan.
And this is Min.